the second part of the diagram. Second question we asked is that I want to now know the relative amount of phases which are present in the two phase region. So in the same point, if I say earlier we have found that okay, the two phases are L and alpha, and the tie line answered that L has nickel percentage. Similarly, alpha has a nickel percentage of, it was answered as maybe 30%, and it was answered as 42%. But now the second part of the question is that in this L and alpha, the two phase region, at this constitution point that we have considering here, what is the relative amount of the phases? Means the total you started with is, let us say you started with some mass of material which you have here 100 here, and you started heating it up, you came here, so it was total 100% solid here, so it was 100% solid here. And at this point you said that okay, now there are two phases, but we are interested to know that the composition is answered already. Now I am interested to know that what is the relative proportion of L and alpha. Means out of the 100% there, what is L, what is the liquid, how much of it is liquid, and how much of it is solid. So this is the next question which we want to answer here, which we will answer with the help of what we call as the lever rule. So the lever rule is similar to the tie line. So what you do, if you remember, that you draw the tie line. So the ends of the tie line were interested in the last slide. Now what we do, that we draw the tie line here, and now I'm interested to find out the relative composition. So for that purpose, if you have drawn the tie line here and it is intersecting the liquidus line here at this point and the solidus line here at the second point, we say that this is the alloy proportion, means it was around, let us say 38%. So when I am at this point here, let us say you started with A, it is all liquid. So it is just like, I'm just trying to show it in a diagram that it is all liquid, single phase, same phase. When you are at point B, this is what it will look like. It has, the green one is liquid, and it has the blue one, which is nothing but there is a precipitate formation and solid formation is visible. Our task is to find out the relative proportion of that. So for that purpose, let us see how you do the lever rule. So the lever rule says that you use to find out the relative amount of phases. So B was the constitution point, A is the intersection on the liquidus line, and C is the intersection on the solidus line. Same way, what I'm saying is that B is the constitution point, A is the intersection of the tie line on the one of the boundaries. So this is the bound, actually nothing but the boundary of the liquid phase or any other phase. Similarly, this one is the boundary of the solid phase. So we actually then say that okay, A is the intersection of the tie line at liquidus line, C is the intersection of the tie line at the solidus line, and now it forms a lever ABC with a fulcrum at B, and that is why the basic fundamental is called the lever rule. How do you find out the relative amount of liquid and alpha? It is pretty simple here. So what we do here, that if I want to find out F alpha here, if I want to find out the composition or the relative amount of the alpha phase, which I'm writing here as F alpha, that is fraction of alpha, fraction of solid. How do you find that? So fraction of solid at point B is found as the solid phase is on the right side. You can see that this is the solid phase here. So we say the magnitude of the opposite arm, not towards the solid side. Magnitude of the opposite arm means AB. This is AB upon the total arm of the lever. Total arm of the lever is AC. Now, how do you read that? You can read it very simply with the help of the composition scale. So the composition axis is here. So you can see here that A is visible to us as around, let us say 34 or 35. And similarly, C is also can be read as around 45. And I can then find out the magnitude of the opposite arm of the lever, that is AB, and divide it by the total length of the lever, that is AC. So AB upon AC will give you what we call as the what we call as the relative proportion of the solid phase, F alpha. And F alpha is here found like AB upon AC. So as I said already that you found AB as 38 minus 33 upon 45 minus 33. This is nothing but this one. You take the length of AB. It is 38. This is 38 minus 33. It is, let's say, 33 here. And the total length of the lever is, I vary it as 45 minus, this is around 33. So the same one, 33 here. And we say it is 5 upon 12. And the relative proportion of alpha, that is solid phase, now comes as 0.416. That means at point B, the solid proportion is around 41.6%. So it can be very as easily seen that if you move downwards from B toward this point, toward the solidus line, and if you have the constitution point here, if I say it is point D, we can very simply see that now if you draw the tie line is drawn here, and if it is E and F, and if I am now interested to find out D, the amount of solid alpha at point D, the basic diagram also tells me that it will be higher because you are solidifying. So from liquid, you started with whole 100% liquid. Here it is, let us say 41% of it is solid. At D, the liquid proportion will be further less and solid will be higher. And we understand that at this point, if I say it is EFG, this point here, below this point, you will have 100% alpha. But at D here, as I said, if you can find out that, you can find out easily here, that is what is F alpha at D. So if anyone can tell me, F alpha at D will be the length of the opposite arm, that is ED upon the total length, that is EF. EF. We understand already that ED happens to be quite large as compared to AB, and that is why this F alpha at D will be higher than what you found at the point B, which is also known to us from the basics of the phase diagram also. So this is how do you determine, how do you use the lever rule to find out the relative amount of phases which are present in a two-phase region. Similarly, if it is containing 41% solid, means the rest of it is liquid, means around 60 around 58% of it is then nothing but FL. That is, fraction of the liquid is 58%, fraction of the solid is 41%. Okay, is it clear?